Chapter 6.5, the properties of logarithms. So we're kind of winding down logarithms now. Just to mention a few of the properties here and make you aware of them. Log base a of 1 is always equal to 0. Log base a of a is always equal to 1. Natural log of e is always equal to 1. Log base a of x to the power m is equal to m log base a of x. This is called the power rule. We simply move the m to the front and multiply by log base a of x. Log base a of m times n, the product, is the product rule. Log base a of m plus log base a of n. Split it up into the sum of two logarithms to base a. This is the product rule. Quotient rule says log base a of m over n is log base a of m minus log base a of n, known as the quotient rule. Other smaller properties, a to log base a to the power m is always equal to m. For example, if you've got, say, 2 to the power log base 2 of 5, the solution is 5. So I want to show you how to manipulate these logarithms. One, rewrite. 1 second here. Okay, I'm sorry, yes. This is write sum or differences of logarithms. And then make sure that you express the power as factors. For example, log base 3 x times y solution is simply log base 3x plus log base 3y. Log base 7 of 343x is log base 7 of 343 plus log base 7 of x. So this is log base 7 to the power 7 of 3 plus log base 7x. Then use the power rule to bring the 3 to the front. So 3 log base 7 of 7 plus log 7x. Remember, the property says if the log and the base are the same, it's equal to 1. So solution is 3 log base 7 x. Log base 2 of x to the 6th power x minus 3. So you start by breaking this down in using the quotient rule. Log base 2 x to the power 6 minus log base 2x minus 3. Use the power rule to bring the 6 to the front. 6 log base 2 of x minus log base 2x minus 3. Please do not attempt to distribute log base 2 here. You can't distribute a word, okay? See perhaps one more example. One or two more examples. Natural log of x over e to the power 6x. This is natural log of x minus log natural log e to the power 6x, which is natural log x. Use the power rule to bring 6x to the front. ln e, which is 1. So ln x minus 6x. And then you may be asked to rewrite, wait, let me do one more example here. I see an example that I really like here. This is log base b u to the power 6 v to the power 5. So this is log base b u to the power 6 plus log base b v to the power 5. Power rule, bring the 5 to the front and the 6 to the front. So this is 6 log base b u plus 5 log base b v. Perhaps one more example. Okay. Natural log x to the power 12 square root of 4 minus x. So recall that this is 4 minus x square root is written as the power half. Then applying the power rule, we have x to the power 12. Sorry, the product rule. 4 minus x to the power half. Then using the power rule, 12 natural log x is equal to, plus half natural log 4 minus x. You may also be asked to rewrite logarithms as a single logarithm. So write the expressions as a single logarithm. Eight log 6u plus 3 log 6v. So you want to start by reversing the process. This is log 6u to the power 8 plus log 6v to the power 3. And then combining to a single logarithm with base 6 u to the power 8 v to the power 3. Three log x plus half log y. This is log x to the power 3 plus log y to the power half. And combining this as a single logarithm, this is log base x to the power 3 y to the power half. And y to the power half is the square root of y. So log x cubed square root of y. Log base 2 square root of x minus log base 2 x to the power 7. So this is a quotient, log base 2. Remember, this here is log base 2x to the power half minus log base 2x to the power 7. So applying that quotient rule here, we have x to the power half over x to the power 7. Which equals to log base 2 x to the power half minus, sorry, this is 7, right? 7 minus 7. So this is log base 2 x to the power negative 13 over 2. And then applying the power rule, we have 13 over 2 base 2 of x. All right, two examples. Log base 4, x squared minus 4 minus 6 log base 4 x plus 2. So applying the power rule, to the power 6, and then using the quotient rule, over x plus 2 to the power 6. Now notice that you can factor the numerator into x plus 2, x minus 2 over x plus 2 to the 6th power. So that 1x plus 2 will cancel with one of the x plus 2's on the denominator and make the power 5. So your final written solution is x minus 2 over x plus 2 to the power 5. One final example. ln x over x minus 9 plus ln x plus 9 over x minus ln x squared minus 81. So rewriting using power and quotient rule, we have logarithm of x over x minus 9 times x plus 9 over x divided by x squared minus 81. So on the numerator, we've got the x's canceling out. We have logarithm x plus 9 over x minus 9. And then if we factor the denominator, we have x plus 9 times x minus 9. So looking at how this is going to play out, this is logarithm x plus 9, x minus 9. Okay, that's the numerator. The denominator, we flip the denominator over and multiply. 1 second, I need to pause this and answer. Okay, we're back. So this is 1 over x plus 9, x minus 9. So x plus 9 cancels out, and this leaves me with 1 over x minus 9 squared logarithm, which is logarithm x minus 9 to the power negative 2. So the solution from the power rule, negative 2 logarithm x minus 9. I don't like the way this is written. Let me write it back for you. Negative 2 logarithm x minus 9. There we go.